by all the theory.
All right, so we started recording for the Spark streaming module. So basically, let's do a quick recap, guys. What do you remember about Spark? What is it exactly?
So Spark is basically a big data processing framework, which basically the essence is splitting up workload for processing data across clusters of computers. So what's called things, obviously, like also things with big data files. If you try to run them in something like pandas, it basically like crash the entire thing. But Spark is basically for being able to handle things like that. And then with Spark, there's like extra extensions. So you've got Spark SQL, which is like an extension for what's called querying using SQL within Spark, and then the other stuff. So like streaming, which is for being able to use, I think it was in real-time data.
Exactly.
Like that.
Perfect. Yep. So you get the idea. That is correct. So basically, we have different tools to handle big data, right?
Yeah.
Hadoop was the original one. Apache Spark is the newer kind of tool. And it has several components. We have the Spark core, right? Spark streaming, Spark SQL or Spark SQL, some people call it. You have GraphX, and you have the machine learning library, right? So all these come with Spark. Spark is built in Scala, and that's why the support it has is mainly for Scala. And that's why here we can see the beginning of the notebook. It says not all functionalities are available on Python currently. That changes quickly over time, of course, as you know, support is increasing. But currently, Spark is the most popular big data tool in companies, and a lot of them use it. And chances are you'll probably end up interacting with it somehow, right? It's used, we write code, we can write with the PySpark code to kind of do data transformations, data wrangling, cleaning, manipulation, integration, all those sorts of operations, right? So that's kind of the idea. And we'll start getting into the details. So here what it's saying is the flow looks like the below. We hook up a data source to Kafka, for example. Incoming data is divided into batches. Batches are then processed by the Spark engine, and the data is returned after MapReduce transformation. So what this is explaining is a very basic, what we call data pipeline that we create in organizations. So what is the data source? Who can tell me? Tafadzwa, what do you think a data source is?
Is that the files which contain the data?
Well,
like the origins for it?
Yes, the origin. So data source is what creates or produces data files for us, right? So what's an example of a data source? Let's think together. Shtiyaq, what do you think?
APIs.
Sorry?
APIs. Maybe.
APIs, yes. What do you think, Tafadzwa? Another one.
I was saying like website forms.
Website forms, definitely. Can a manual data entry person be a data source?
Yes.
Yes, you can. So although the majority of data produced these days is actually machine data, statistics show it's 80% of the data now, data being produced. But humans is still 20%. So we have machine forms, website forms. You have like, I was working on, one of the modules today for big data kind of interaction and transformations. And the use case we're presenting is from Emirates Airlines. It's the check-in system. And a large part of the check-in, flight check-in system is manual data entry from the staff at the counter. When you go to check in at the airport, you give them your passport and your ticket. Yeah. And they check their system, take your luggage, and give you a boarding pass. And they type some stuff on the system, press enter, and then you're good to go. That's manual data entry. And that's actually still widely popular and still widely used. So that's a data source. If we connect to something called Apache Kafka, which is, you know who it is, or what it is, rather?
Yeah.
Well, Tafadzwa's done it. But I haven't done that stuff
give me an
yet.
idea.
So it's like a, how to explain, like a data log system. So it takes data and turns it into logs.
Well, you're on the right track. It's more of, it's a data pipeline, we can say, right? We can think of a resemblance between that and a water pipe, right?
Yeah.
The idea is to put data from one side and get the data out from another. Why would we use this? It's a tool basically to help us control the data flow, right? If we have data coming in very quickly, especially if it's machine data, like data from mobile apps, for example, we need some sort of intermediate tool to create that pipeline for us, to help organize the data, store it, as it comes in, make sure we don't lose any data, make sure we don't have any duplicates, and has the ability to connect to different, what we call consumers. A consumer in Kafka is basically a user of the system, right? So you can have, for example, if we use that Emirates Airlines check-in counter, those old terminals in, black and green text they use, that could connect in the backend to Kafka from the mainframe, and that sends it to a big data lake, which has Apache Spark. So Kafka can be used for that in this use case, right? So that's how we connect them.
Sorry, I have a question regarding Kafka.
Sure.
Because when I was searching this stuff up, there's like a lot of articles which seem to like intermingle Kafka and streaming. So I was just trying to understand what is the actual difference between Kafka and Spark streaming.
They're completely different tools. So Spark is a world on its own.
Yeah.
Spark can be used without Kafka.
Okay.
Right? Spark is data processing engine.
Okay.
Kafka is like a data pipeline. It's used to transport, move, and send data from point A to point B. It has something called Kafka streaming. That's why it's confusing. It's one of the features of Kafka. Kafka can perform very basic data, I wouldn't say transformations, but data processing tasks on the data as it's moving.
Oh, okay.
Through the pipeline. But the end goal is Kafka will probably send the data to Apache Spark, where then you can use the Spark streaming on the data that's coming in. So Kafka connects to Spark streaming, but they can be used separately. You can use Kafka with something else like Hadoop or Postgres, for example.
Oh, okay. That makes a lot more sense. I didn't know Kafka had streaming as well.
Kafka supports streaming. So it can be used for batch or streaming and real-time data movements, data ingestion.
Okay.
Right? So I hope that clarified the confusion a bit. And then point number 2, it says incoming data is divided into batches. So the way Kafka works is that data's coming in, could be real-time, the definitions of real-time or streaming or batch really depends on the time difference on how fast the batches are being moved and being processed, right? So at the end of the day, we're moving data in batches. It could be very small batch if it's really fast, or very large batches if it's very slow batch process, right? That's the whole concept. Then point 3, it says batches are processed by the Spark engine. So after the data arrives to, let's say, a Hadoop cluster, a Hadoop big data lake, we store this data on HDFS usually. Or if it's a cloud, you can store it on Amazon S3, for example. So those tools would just capture and store the data. Spark is used as a layer, abstraction layer on top of the data storage to perform any data cleaning or data transformation or ETL or ELT tasks, right? And the way we do that is you write code with either Python, Scala, or Java. And we send that code once you create a code and you run it within Spark. Spark transforms that code in the backend to MapReduce. And that's why point number 4 here, it says resulting data batches are returned after MapReduce transformations. Does that make sense?
Yeah.
Yeah.
Okay. So at a high level, again, just to recap this point, we have in any major, company or enterprise for their data engineering platform, you have something that produces data, which is called a data source. You have a tool to move the data called data ingestion tool. Here it's Apache Kafka in the example.
Yeah.
You have somewhere to store the data when the data goes, right? Usually Hadoop HDFS or a cloud, S3, for example, bucket. Then you have a tool to do data processing. Processing means cleaning, transformation, integration, etc. In this case, we're using Spark, Python on Spark, right?
Yeah.
So that's kind of a summary of these key points. Now, moving on, we're getting into some terminology related to the Spark streaming component, right? These streams, it's an acronym for discretized streams, or discretized streams, rather. What is it? It's a high-level abstraction over streams of data which allow us to easily work with it. So these can be created either by reading directly from a data source or modifying existing G streams to create a new one. So these streams in turn represent a sequence of RDDs. So RDD, it's kind of a Spark concept. Do you remember what it is, guys?
I forgot, what does it stand for again?
You remember it, Fadzwa?
Vaguely, but not completely. No.
So it was called resilient distributed data set. It's the data abstraction used in Spark. Remember how in Python we had data frames?
Yeah.
Indeed.
Yeah. Spark also has data frames when you use Spark SQL. When you use regular Spark, they're called RDDs. So RDDs are, we can think of them like it helps us store a collection of records. It's read-only, and it records the operations we want to do, right? It's kind of a variable, kind of. So we can think of it that way. But it's the terminology that Spark uses. We can discuss it in more details later, but just so you know at least what that means, since we came across the term. So next, we go to receivers. What that says is every D stream, except the file itself, is connected to a receiver. A receiver's job is to receive data from a source, store it in Spark's memory for processing. So again, a receiver in this case would connect to Apache Kafka, right? It's receiving data from a source. So if you have Kafka connected, it'll connect to the receiver of the Spark streaming application. And the way Spark works, it stores data in memory. What does that mean, in memory? Does anyone know?
In the RAM.
Correct. Well done. It's in RAM. The reason why Spark is actually more popular now than Hadoop and data processing, Hadoop used disk for processing. Spark uses memory, in-memory processing. For a lot of use cases, that was much faster. Of course, it needs more RAM. You need more, for your cluster, you need more resources. But it was a significant improvement. And that's why for some use cases, Spark can be 10, 20, 50 times faster than Hadoop, actually. So this is what a receiver is. It's just a terminology. And point to remember, if we move on, we have a single receiver used on a thread. If we use a single thread, there will be no threads left to actually run data processing. So this is more about tweaking resources. We should give more cores than receivers we would like to run. We can run multiple streams to get data from different sources. Yes, so this point is important. It's not a one-to-one relationship, right? You can connect multiple sources at the same time. Does that make sense?
Okay.
Like you can have, data coming in from a website, from a mobile app, from manual data entry, from another database, and they're all connected. They're all coming in. Could be many-to-one relationship or many-to-many as well, right? That's why it can get pretty complex in the real world.
Okay.
File streams are an exception as they periodically create a system for new files. So the file streams is another component. Can we scroll down a bit? Still? Yeah. Okay. So it's saying, let's start by creating a Spark session. You should always start like that, right? Spark session is needed in our code. It's kind of like how you don't have in Java a main function always.
Yeah.
Something like that. So you always need to create a Spark session, which is a temporary and stores, the variables, the configurations, etc. we'll be using during our session. So, yeah, if you run that, import find spark initialize. Receivers can be split into two wide categories. We have reliable and unreliable. You're running in VirtualBox. Okay.
Yeah.
We don't care about send acknowledgements. Okay, coding. So let's start by creating a session. So that part worked. Next step.
Regarding this, I want to ask.
Sorry?
When I was regarding this part, I wanted to ask. Regarding creating the session, usually I saw that what they do is they just create a session by PySpark.sql.spark session or something like that, and then they don't bother with this part.
So some of these are mandatory and some are optional, right? So setting the master, you can sometimes include or not include, but it could give you errors. So this master is used to specify if it's a local machine or, if it's a big cluster, you tell the system which node will be the master node, right? App name is important if you want to refer to it. Sometimes it gives an error if you don't have it as well. But some things are important, like you have to have this conf equals PySpark.sparkconf. This multi-processing CPU count, etc., is just to kind of create multi-threading. Okay. Right? Set app name, test app, that's just the name. And get or create, you need that command to actually run and create that text. Sorry, that session.
Okay.
So now let's see what the error is. It says your host name resolved to a loopback address.
Errors, they're not from here. It starts coming. Where are they?
That's a warning, though, right?
Yeah. I think. Let me start.
So let's go step by step so that
Yeah.
we don't confuse ourselves.
Okay. So I'll go here next.
So let's continue. Well, one error here, it's saying unable to load native Hadoop library for your platform. Usually we also need to set Hadoop home and download and set up some parameters for Hadoop. So let's see if that will be an issue or not. It could be one of the problems we have.
Okay.
All right. So let's move on, streaming context. So after that, we can create PyStart.streaming context. So what we created above is just the session.
Yeah.
Right. For Spark's for PySpark SQL, it is not Spark streaming, not yet.
Okay.
This part of the code is what creates the actual, or starts creating the streaming context. So after we have the Spark session, we need to create the PySpark streaming context object. And it takes Spark context as input. It can be the one we're using for other functionality. It does not work with one of the object directly though. So we have the code here from PySpark streaming, import streaming context. Does that run?
Yeah.
Perfect. Did you click on it? I didn't see.
Yeah, I did.
Okay, great. So here we have batch duration equals 30. So that's just one of the parameters we can tweak to kind of tell it how long the batch should last, right? Because streaming data keeps coming in continuously.
Okay.
Correct? When you give it a time, you're saying cut off here, this is batch number 1. Then data collects after 30, I believe this is seconds or milliseconds, I'm not sure, but my guess is it's seconds. It would stop batch number 2, right?
Okay.
So that's how it works. So important things to notice, we set up the whole computation pipeline first. Nothing is started until we use ss.start and finish with ssc.end. So these two commands are important to start the actual streaming context and to end the streaming context. Okay. So some methods of interest. This is just extra information, so you know what we're dealing with. SSC, what does it stand for? Who can tell me?
Spark streaming context.
Spark streaming context, correct. So Spark streaming context, await termination after a certain timeout. Spark streaming contrast checkpoint. Get active or create. So if there is an actual stream started and not stopped, return it. Method start and stop. And create streams from the context. So we have socket text stream. You give it the host name and the port and storage level. You tell it to like be basically on standby. Storage level means where to store. We have different types of storage. SSC text file streams directory is to watch for new files created on Hadoop compatible system and read them as text files, right? Watch means basically monitor and be on standby to consume data as soon as it arrives, right? So if this folder is empty, this method does nothing. If data starts coming into the folder, it automatically starts consuming it, right? Ingesting it. SSC binary record stream reads the files as binary. So these are just different types of input we can use, right? So let's scroll down a little bit. Yeah. So given all of that, let's create a D stream via socket text stream. So this is the type we will use, which will listen on localhost for data incoming to the machine. So what this is saying is we're creating a very simple streaming application on our local computer using port 9999. Okay.
Right. What does the port 999 refer to anyway?
I think it's just a random port.
Okay.
Let's also apply some transformation. We'll split the text into words and find the result, count unique words in the text. So unique words is this. We use a flat map. We just flatten in the lambda function and then count. All right, so let's run that. Oops. Yeah, unique words. So do we know what this function is doing, or rather this RDD?
It's just splitting the text into different sections.
Correct. So this is a very nice, neat way. That's why I like Python, Scala, and Spark. In Java, this would be like a big, huge block of code. What this is doing is it's creating a new RDD called unique words. And it's telling it, you know, take a text, split it, flatten it. We need flat map. And then count by value to count the number of words, right? And lines dot means for every line, basically. So for every line in the text, check the word, you know, do the flat map transformation on it, split the text into separate words, count by value for each word, and return the results to the unique words RDB. So it stores the value there. And then .print produces the, or pprint for pretty print, gives us the output, right? So if you run that, and then the notebook says, notice nothing has happened yet, which is correct. This is because our computation hasn't started yet. In order to do this, we have to run ssc.start. So before we do that, let's run netcat to push some data to our socket. So that answers our earlier question, Ishtiaq, on, you know, what is that 999 port doing? So this is kind of going to generate some data that we can use theoretically. And let's see if that works. So we need to use the -- listen flag and PySpark socket expects server, which connects to the address. Let's run the interactive command, send text locally, system. All right, so 1 second. What it's saying here is run this in a separate cell in order not to block the execution of this notebook.
Separate cell. Okay, this is separate.
No, I think what it means is like another, it looks like it's going to keep running, so it will freeze the notebook. So you might want to either duplicate the notebook or run this in a terminal, I believe. Yeah, just run that. Yeah, copy,
Running.
don't cut, keep it there so you don't lose it.
Wait, how would we run it in the terminal? So we just...
I think this is, which command is this? This Python or is this Linux bash? I didn't get a chance to.
I think it's bash because it's got flags.
Yeah, if it's bash, you can just run it in git bash terminal or Linux, if that's it, depending on your system.
Yeah, do I have to be in the folder where the notebook's located?
I don't think so. Invalid option minus
How do you switch it? The kernel.
bash.
Okay, it's not. Oh, it's for Python. Okay.
Yeah, it's not working in bash for me, so I'll make another notebook.
It could be PySpark. But wait, can minus this and minus P.
Added option.
Netcat. Can you type netcat?
What is net? What is that anyway? Netcat. I have to install it.
Not defined. Okay. Might need to restart the kernel. Still not working. So what does it look like? It's
It's saying you have to install netcat.
what we just did. Maybe we need to
Import PySpark or something.
Okay, still not working.
Now, let's see if this 9 months.
Oh.
invalid option. So one of the options it doesn't like. Which one is it?
It's the
maybe we need no, there is a small p, source ports.
It says dash.
Okay, let's check.
Oh,
what'd you get to?
I got rid of those the double dash. And that error goes away.
Which one?
Well, that's the original line.
Ah, it doesn't like double dash.
Yeah.
So it ran. Can you scroll down?
If I do just no double dash, then I don't get any.
Oh, but it still gives usage and
usage. Yeah.
something doesn't look right. It should give like a green check mark or executed.
So it's
Oh.
port.
Okay.
Maybe. Okay. So
Go back and
See, maybe take off the exclamation as well.
now
Because
try
when I
minus L instead of listen. I'm just looking at like a guide here. 1 minus and L. Yeah, try that. There you go.
okay.
So I guess it doesn't like listen. The new format is minus L.
Oh, so it's been updated.
Possibly.
Okay.
All right. So congratulations. You passed one roadblock.
So is it just gonna stay like this? Or...
Yeah, keep it like that. Let's go back to the notebook. Let's see what it says here. So now it says now you can run start, which will run indefinitely, but will not stop Python's program execution. So let's scroll down.
Can you explain again why we did this in a different notebook?
Well, as it's saying here, what is this doing? Let's take a look. We need to run netcat to push some data to our socket. Please note that minus listen flag specified, which means we have created a server listening on a specific port. PySpark socket expects to find a server which can connect. So let's run this interactive command. It allows us to send text data to localhost 9999. Make sure you have NC or netcat available in your system. Run it in a separate cell in order not to block the execution of the node, because it will keep running indefinitely, right?
Oh, okay, yeah, that makes sense. Because that's why over here you can see it doesn't end.
Exactly. So
Okay.
if it was in that notebook, it would freeze the page and we'll be stuck. Right?
Okay. So with the bash, it's just blinking. After running, it's been confirmed. It's gone to the next line. Nothing's come up, but it's just blinking basically.
Yeah,
So it's
running. That's the expected behavior, actually.
Okay.
All right.
So
yes.
netcat is just some library which lets you input text data. That's what I'm guessing. Is that what it is?
Well, I'm not certain of the exact definition, but I believe it's a function that allows us to push and consume data from a specific port in our system. Right? It looks like a Linux bash script feature.
Okay. Because I remember pip installed it, so I'm thinking maybe it's some sort of library. Something.
It's a good question. So it's a utility for reading and writing data from network connections using TCP or UDP. That's the exact definition. So it's a Linux bash utility, basically. I've seen it before. You use it to like listen on different ports and copy data. Right? All right. So next it says, now you can start, but we'll run indefinitely. Will not stop. Due to above, boom. So we ran that successfully. Let's run the seconds command again successfully. Did that work?
It's running now.
Yeah.
What are all these errors though?
Oh, these are from before when I ran this like a few weeks ago.
Okay.
So like,
can we remove them somehow so we don't confuse ourselves? Make it look nice.
I have to restart the entire panel then. Okay, it's working good now.
This thing's running, isn't it?
Yeah, it's running. Yeah, what is await termination again? I don't remember. Process data indefinitely for up to a moment. Timeout is hit.
We have a timeout there. It's defined. So let's go down.
So it's 180 seconds. So that means how many batches will be processed? 60.
Actually,
that's 6 batches. So.
Try typing something in the other. Can you open the other notebook we have?
Yes.
Type something. Can we enter data there? Just like put some hello world. No, just put hello world, like the text. Enter. Let's see what happens. You go back to the notebook. Does anything show up here? Let's scroll down.
Now it's been 180 seconds. Yeah.
Oh, because what's supposed to happen, this netcat is supposed to take the data and we're supposed to send it to the RDD to count, right? So where is Does it mention in the notebook where the text should show up? But we did.
Until the PySpark terminates the connection. So what's that? How much longer have you got? Another minute.
It doesn't really say anything about what's supposed to appear. Kind of goes, finally we can stop PySpark client.
Let's let it finish. I'm not sure what the expected behavior will be, but let's let it finish and see.
Another 30 seconds.
But what's supposed to happen is we use the other terminal or notebook to enter text data, which will be consumed in this command that's running for 180 seconds. And it's supposed to take these words, put it in that RDD we created, and do the flat map and the word count. So that's what should happen. Even if it doesn't work, we can assume it works. That way we just understand what's going on.
Okay.
So we can move on. We can come back to that later. But that's the expected behavior, right? We're creating a data input basically to our application.
Yeah.
And this data input will be used to do those transformations.
Thanks. So running. Yep.
I think
I know
it's
it's
been
run now.
more than 180 seconds.
Yeah, it's finished running now.
Finished?
Pretty sure. Because the star, what's called the asterisk, isn't there anymore. So I guess it's finished running.
But it didn't show any output, although we had print. All right. Well, at least we understand what's going on, guys.
Yeah. So
Makes a lot more sense.
like it's gonna look out for data coming through that port.
Yes. So what we're trying to do is simulate data entry because we don't have files right now. Where we're feeding that file or ingesting it into our application in PySpark. And once we have the data in PySpark, we can manipulate it using RDDs, right?
Yeah.
And the idea of having it run indefinitely, it's simulating a streaming application, which will bring in data continuously.
It have to be in the same line.
Not sure. Let's give it a try if you want.
Let me drop this to 60 seconds. Let me take this long. Stop. What?
Doesn't like it.
Okay, that's it. Might be because we ran that line of code before we put in the hello world as well.
Could be. Could be.
Let's try it again.
Type something else, like hello world, and add something, so we know it's our next attempt. Okay, let's try running that again. So now what Spark is doing, it's taking the code application, transforming it into MapReduce in the back end and running it.
Yeah.
Right, running it locally on our machine. It's a single node machine. Anything showing up? Yeah, maybe we should do the print after. Nothing came out.
If I rerun these lines. Okay, I don't get errors with those.
What error you get?
Adding new inputs, transformations, out operations after starting the context.
So we can't run it there.
So we have to run these before we run the netcat, is all I'm assuming.
So it is the correct order. But yeah. All right. Well, let's move on. At least we know what's supposed to happen, right?
Yeah.
So let's see what the next task is in this notebook.
After context, that's good. To finish on the auto.
It says, finally, we can stop PySpark client handling incoming data using stop gracefully. So if you run that,
A bunch of
warnings.
See, I'm getting an error now saying restart receiver with delay. Error connecting to the local host.
Yeah, that's a different error. That has something to do with the settings.
Okay.
So nothing ran for you?
No, it was working before, and then I was getting a random error, and I did rerun everything, and then it was saying, "What's it? Warning: receiver supervisor, impl, restarting." Should I just share the screen real quick just to see it?
You can run them in order. Try to run them in order. Everything from the start again.
Yeah.
It might be easier if you want. Copy paste them into a new notebook, like how we did with Ishtiaq, and just put them all in a row, like in sequence, so you could just run them quickly.
Yeah, true.
software. Fix those. Oh, okay.
You can try something. So I'm sharing a different syntax for netcat on the screen. This doesn't work.
I was gonna say, should we reorganize it so then the unique words dot print runs after everything?
No, it gave an error when we did that.
Oh, okay.
It wouldn't let us.
Trying to netcat. What was the line again?
Yeah, so echo minus n something like hello world in single quotes, and then we have pipe netcat nc IP port. So the IP would be 127.0.0.1, which is localhost. And
Oh, it was 999.
yeah, 9999. Not sure if we should put them in those brackets. Let's try. IP is 127.0.0.1 for local use.
127.0.
Local use.
Wait, these are separate lines, right? Not the same one.
Yeah. So you can comment out that first NC minus L one. Try that echo thing. Let's see what happens.
Syntax. Maybe.
No, I think it could.
Double quote.
Oh no, it's this NC thing.